Alright, this video is about the remainder theorem. And the remainder theorem says that if we divide by, let's say, x minus 2, if we divide this function, this polynomial by x minus 2, the remainder that you get is the same thing that you would get if you evaluated the function f at 2. In other words, the remainder that you get will be the same thing that you would get if you plugged into and substituted for all the x's. Okay, so we're going to use that fact to quickly evaluate functions using synthetic division. Alright, just this once, let's go ahead and show the evaluation by direct substitution, and then we'll show it by synthetic division as well, so you can see that it's the same thing. So if I evaluated the function f at x equals 2, alright, of course that means substituting 2 for all the x's, like so. Alright, I know you like how I use these parentheses. Anytime you're substituting in for a variable, always use parentheses where you're substituting. Leave that negative out of there. So negative 2 to the third power is 8. I'm sorry, 2 to the third power is 8. Notice that negative sign is not being raised to any power. It's just sitting there. Anyway, we've got plus 12 and then minus 7. Okay, so putting these together, that's going to give us 4, and then minus 7 is going to give us negative 3. Okay, so f at 2 is negative 3. Now, according to the remainder theorem, the remainder, if we go ahead and divide the polynomial by x minus 2, the remainder that we get should be the same thing as f at 2. Alright, the remainder should be negative 3. Now, if we were to divide by x minus 2, the first thing we would do is set this x minus 2 equal to 0 to get x equals 2. So that's what we would put in the little synthetic division box. Okay, the x equals 2. And then the coefficients. We've got the negative 1 from the x to the third power. The x squared term is missing, so we'll put a 0 there for our 0x squared. That's absent. And then we'll pick up again with the 6 and the negative 7. Okay, so we'll bring this guy down. So negative 1 will multiply and add, multiply and add, multiply and add. So notice that the remainder is the same thing we got when we did direct substitution. So for the rest of this lesson, I'm just going to use synthetic division, but just understand that whatever remainder that we get, that's the same thing we would get if we took this same number and substituted it for all the x's. Alright, and that is what the remainder theorem tells us. Okay? Yeah, so the answer to the question that we're looking for is the negative 3. Okay, on to problem number 2. Now, there are many problems in this lesson, so I'm going to work as fast as I can. So we've got the 2 and the coefficients. Let's see, nothing's missing. 1, 1, negative 5, negative 6. So bring down the 1, multiply, add, multiply, and add, multiply, and add. Okay, so f at 2 equals -4. Alright, let's try number 3. Now at this speed, and you don't need to know my problems, but I got 0 sleep last night. I mean literally none. So I'm just warning you ahead of time, I'm bound to make a mistake. Please forgive me. So we've got the -3. Hold on, let me save this document. We've got our -3. Let's see, 3, 2, 1, 0. So nothing's missing. 1, 3, 2, 8. Okay, so we drop this down, multiply and add, multiply and add, multiply and add. Okay, so that means f at -3 is equal to 2. Alright, number 4. Alright, we are evaluating the function at -2. 3, 2, 1, 0. Nothing's missing, so 1, 5, 10, 12. Okay, bring down the 1, multiply, add, multiply, add, multiply, and add. Okay, so f at -2 is equal to 4. Alright, this time we're supposed to evaluate at a value of 3. 4, 3, 2, 1, 0. I always like to just make sure that there are no missing terms right at the beginning. Because if there are, got to use that 0. You know what I mean. Okay, drop it down. Multiply and add. Multiply and add. Multiply and add. Multiply and add. Okay, that means that f at 3 is equal to 8. Have I made my mistake yet? Alright, I am just not going slow enough to catch any mistakes I make. Alright, hopefully it won't be too many, and I can just fix them with little pop-up bubbles on the YouTube video. Let's see. So one more time for this activity. We're evaluating at 7 this time. 5, 4. 4 is missing. 3, 2, 1, 0. Okay, so we will have a 0 term right here. 0x to the 4th power. So watch out for that. Okay, so we will have 1 and then 0. And then -47, big number. -16, 8, 52. Some big numbers in this one, whatever. We're not scared. Plus we have a calculator. 1 times 7 is 7. Add them up. Multiply. That's 49. It's 2. Multiplying here, you get 14. Add those up, you get your -2. Multiply. It's -14. 42. So that's 10. 52, 42, yeah. So that means f at 7 is equal to 10. Okay, we just dominated that. Alright, hopefully you can see how fast you can evaluate using the synthetic division way of doing it. It's many times faster than substituting for all the x's, even if you're using a calculator. So it's very quick. Also, this is the type of thing a computer could be programmed to do. Okay, now, so we're switching directions. State if the given binomial is a factor of the given polynomial. Well, if it's a factor, then it should divide in evenly. Okay, in which case there should be no remainder. Alright, so is it a factor? Then we're asking, it should be remainder equal 0. Okay, so let's check it out. So if we see a remainder of 0, we'll say yes, it's a factor. Otherwise, we'll say no. Again, so if we have k minus 2 is the factor, then the potential 0 is k equals 2. Alright, we're setting this equal to 0 and solving in our heads. So understand that it is 2 that will go in the box, not negative 2. Alright, 3, 2, 1, 0. So I've got 1, negative 1, negative 1, negative 2. Okay, multiply and add. Multiply and add. Multiply and add. So we don't need to put the variables back in. We see that the remainder is 0, and so we will just simply say yes, because they asked us a yes or no question. Is the binomial a factor? Well, we got remainder 0, so yes, it is a factor. Okay, meaning it divides in evenly. Alright, so you see the process. I'm going to speed up a little bit on this now. Okay, so yeah, if I go with the 7, alright, because if this is the factor, then b equals 7 would be the 0. 4, 3, 2, 1, 0. So 1, negative 8, negative 1, 62, negative 34. Okay, bring it down, multiply, add, multiply, add, multiply, and add. That's 6, multiply, we get 42, and that makes 6. So that means no. This is not a factor because we did not get a remainder of 0. Okay, and again, if this is the factor, then the potential wannabe 0 is negative 8. So negative 8 is what goes in the box. 4, 3, 2, 1, 0. 1, 9, 14, 59. It is easy as pie. So I've got multiply and add, multiply and add, multiply and add, and multiply and add. So that's a no, because that is not a remainder of 0, so it did not divide in evenly. Okay. Alright, again, if this is the factor, then the potential 0 is p equals negative 5. So it is negative 5 that goes in the box. 4, 3, 2, 1, 0. 1, 6, 11, 29, negative 13. Alright, bring it down. Multiply and add. Multiply and add. multiply, and add, multiply, and add. So that is another no. We did not get remainder 0, so that thing is not a factor. Let's see, how many more of these are there? Okay. Alright, I guess I'll finish these 4 problems, even though that's going to make this video a little bit long. Alright, a little short on time today. So we will do p equals 2 for our evaluation. 4, 3, 2, 1, 0. 1, negative 8, 10, 2, 4. Okay, bring that down. Multiply and add. Multiply and add. Multiply and add. Multiply and add. So we have a remainder of 0. So yes, that means p minus 2 must be a factor indeed. Okay. Alright, once again, why am I using p? It's n now. N equals negative 5 is what we're going to be looking at as our potential 0. So negative 5 goes in the box. 5, 4, 3, 2, 1, 0. We have a missing term here, so be careful. We've got our 1 right there, but then we've got a 0. 0x to the 4th power is missing. Okay, and then we're back with the negative 25, and the negative 7, and the negative 37, and the negative 18. Bring down the 1, multiply, and add, and multiply, and add, and multiply, and add, and multiply, and add, and multiply, and add. Alright, it's always a little disappointing when I don't get the 0. I'm just always rooting for it to divide in evenly. I'm not sure why I care, but I do. There, I said it. Okay, let's knock out 2 more of these problems. Okay, so once again we will use x equals negative 6 as our potential 0. 5, 4, 3. Aha! Always watch out for the missing 0 term, which we do have on this problem. So I will have our 1, 6, and then 0, negative 3, negative 22, negative 29. Okay, multiply and add, multiply and add, multiply and add, multiply and add, multiply and add. Aww. not a factor. Wah, 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 wah. Okay, I feel like I should check some of these answers on the answer key before I get too far. I guess I'll check after I do this one. Alright, one more problem on this video, and I'll have to stop the video before it gets out of control. Sometimes the video takes on a life of its own. It's alive! And that's not always a good thing. So, -2, and then I have 4, 3, 2, 1, 0. Okay, nothing's missing. So 1, 10, 21, 6, -8. Yes, bend it like Beckham. Watch that movie with my daughter, my wife and daughter, this evening. An oldie but a goodie. You youngsters out there, you've probably never heard of it, but it's one of those ones I think you would enjoy even after all these years. Keira Knightley and some other people. Let's see, we've got 8. John Rhys Meyers was in that. He was the king, King Henry in the Tudors. Tudors? I think that was on HBO or some such. Let's see, -16. Superman was his best friend. I can't add like this. It's 5. -10. -4. +8. Yay! Finally, we have a winner! Yes! Yes! It works! Okay. So, that one was a factor. Alright, I'm going to stop this video here. I'm getting a little crazy, and the video is getting a little long. But we will pick up the next video with just more straightforward division. So we will, this is really review. We did this before, but so the answer will be an actual quotient, some sort of polynomial, not just a yes or a no.